Okay, so let's work through these modulus questions. The first question, sketch the graphs of y equals x squared minus 4 and the modulus of y equals x squared minus 4, indicating the points where the graph meets the x-axis and the y-axis. So if we start off with y equals x squared minus 4, you should know from your AS modules what that graph will look like. Graph of x squared is a U-shaped graph, and that will move it 4 units below the x-axis. To work out where it crosses the axes, if you put x as 0 into that, you're going to get 0 squared, take away 4, y will be negative 4. So that's the point 0, negative 4. To find out where it crosses the y-axis, sorry, the x-axis, you put y equals 0. So x squared minus 4 equals 0. X squared is 4. Then you're going to take the square root and you'll have plus or minus 2. So on our graph, we've got 1, 2, 3, 4. So minus 4 is there. We've got plus or minus 2 there and there. 1, 2, 3, 4. 1, 2, 1, 2. So the graph of x squared minus 4 is going to come down like that, back up like that. Negative 2, positive 2. Okay, and if you want to check that on the graphics calculator, y equals x squared minus 4, hit graph, and that's it. So I know I've got those marks. Now what happens for this is saying that when the output is negative, so it doesn't matter what the values of x are, but when you work out x squared minus 4, when that output becomes negative, it becomes the positive equivalent. So minus 3 would actually come out to be positive 3. So the effect of that is that above the x-axis it's the same, but when we go below the x-axis it is bounced back to its positive equivalent. So negative 4 will become 1, 2, 3, 4, positive 4, and this part of the graph would then do that. So it's always positive, 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 negative bounce, negative bounce, negative bounce, negative bounce, negative bounce, positive, 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 positive. So the graph of modulus y squared, y equals x squared minus 4 looks like that. Now if you want to plot that on your graphics calculator, on the graphics calculator, the modulus function isn't called the modulus, it's called the absolute value. So you would choose to get the absolute, which is there, abs, then you would type in your x squared minus 4. Oops. X squared, take 4, close bracket, and graph that. And there you see that bounce that I described between minus 2 and plus 2. So that's part A, and then for part B we have to solve the inequality 5x minus 3, modulus of 5x minus 3 is greater than 4. Now, the way that I would suggest you do that is you need to be careful with the inequality, because when you're dealing with negative numbers, if you end up multiplying and dividing by a negative number, that inequality flips over. So for that to be true, either 5x minus 3 must be greater than 4, so the positive value of that. So when you do that, to undo the negative 3, you're adding 3 to both sides, so that doesn't change the direction of the inequality. So 5x is greater than 7, so x must be greater than 7/5. So either the positive value of that must be greater than 4, or if that was negative in there, so either the positive value of that must be greater than 4, or the negative value of that. Now if I multiply by minus 1, then that becomes an inequality flip. So timesing both sides by minus 1 means that that side becomes positive, that side becomes negative, and you have that inequality flip there. Because you're multiplying by a negative number. Then we can go ahead and finish solving it. So now we've got negative 4 plus 3, so 5x is less than negative 1, so x must be less than 1/5. Now those two values are not continuous. X can either be greater than 7/5 or less than minus 1/5. So you cannot combine those as an inequality. So therefore x is greater than 7/5 or x is less than minus 1/5. And it's important that you make that all clear, that you're not saying and. It can't be between them, which would be and. They are mutually exclusive. Now you should be able to plot that on a graph as well. So let's see what this one would look like. So rather than apps of that, we're going to do the absolute value of 5x minus 3. And you can see that that looks like that. And then if I plot the line 4, y equals 4 as well, you can see where the intersections are. Now what this is saying is that I want the regions where it's greater than 4. So it's from there beyond. So you're looking down at the graph to see where that crosses, and that will be minus 1/5. And on this side, again, you want above the graph, above that intersection, so you would read that off, and that would be the 7/5 there. So again, graphically, sometimes it helps to draw the sketch. So that's question 1. Question 2. Sketch the graph of y equals the modulus of x for values of x from -2 to +2. Okay, so question 2. Well, that's an easy graph to draw because it's y equals x. Even easier on squared paper, which is why I've chosen this pad. So y x, and I'm going from -2 to +2. So if I go 1, 2, minus 1, minus 2, 1, 2. So the graph of y equals x would be the diagonal line going down like that. Because it's modulus, this side of the line, where it becomes negative, bounces back on itself. So negative 1 on y equals x would equal negative 1, but on this one it's going to equal positive 1. So the graph of the modulus will look like that. So that's y equals the modulus of x. Solve the equation 2x plus 3 equals 4. So the equation 2x modulus 2x plus 3 equals 4. So we work with that until we get the modulus part of it on its own. So 4 take away 3 is 1. And then we go to the either or. So that means that either 2x, the positive input in there, equals 1, which is x is a half, or the negative value of that equals 1, because that's going to be forced to become positive, which means x is minus a half. It's not an inequality, it's just an equals, so that's all they're looking for are the two values rather than a range of values. Part C, however, is an inequality version. So with this one, we've got 3x plus 4 is greater than 5. So we haven't got any manipulation to do. That is an inequality in its own right on the left hand side. So here we're going to say either the positive form of it must be greater than 5. So 3x must be greater than 1. X must be greater than a third. There's no multiplying or dividing by a negative number, so that's fine. Or the negative version of what's inside there must be greater than 5. Times out by minus 1 to get rid of that negative, and that will then give us our flip in the inequality. So 3x will be minus 9, take the plus 4 over, it becomes a negative. Then we're going to divide by positive 3, giving x being less than negative 3. So again with this one, it's not a continuous region, so x is greater than a third, or x is less than negative 3. So that's question 2. Question 3. Okay, solve the following. 3 modulus of x plus 4 equals 6 minus 2 modulus of x. Now, the modulus of x, because they're both the modulus of x, we can treat those as a variable in their own right. So that's like 3 apples, 2 apples, we can combine them. So let's get all our x's together on one side, numbers on the other. So we've got negative 2x there. When we combine that on the other side, it becomes a positive 2x. And on this side we'll have 6 take away 4. So 3 apples plus 2 apples then will be 5 apples. 3 mod x plus 2 mod x is 5 mod x. 6 take away 4 is 2. So the modulus of x is 2/5. So that means that either positive value of x is 2/5, or negative value of x is 2/5, which means x is minus 2/5. So x is plus or minus 2/5. So that is A, and then for part B, it's another one of these inequalities. So again, we need to split it up. Positive value of what's inside the modulus brackets. So either 7x take 5 is greater than or equal to 3. 7x is greater than or equal to 8. So x is greater than or equal to 8/7, or negative value of what's inside there. Times by the -1. Flips the inequality to -3. So 7x is less than or equal to 2. Take the -5 over, becomes a plus. So x is less than or equal to 2/7. And again, those are it's not a continuous region. So x is greater than or equal to 8/7, or x is less than or equal to 2/7, but nothing in between. Question 4. Question 4, we've got to sketch the graph of y equals ln x. Well, should be one that you can recognize. I'll plot it on the graphics calculator shortly, but let me just show you, if you can't remember that, hopefully you will remember what the pattern of EX is. Certainly that is one that you need to know. So hopefully y equals e to the x is one that you will remember. When x is 0, it'll be 1. And what happens with y equals e to the x is it travels from -infinity, where it's very close to 0, through 1 and beyond. So if you can't remember what ln x looks like, then you need to be able to remember what that looks like. And then you also, from the functions work that you did in C3, you need to remember that inverse functions are reflections in the line y equals x. So I'll keep this axis so that it's the same on both sides, because otherwise it's difficult to plot. So I know that my ln x is an inverse function of that. So it's got to reflect in the line y equals x. Now, when you're reflecting in the line y equals x, it's easier if you turn your page around so that the reflection line is running along your line of sight, because your brain is wired to make it easier that way. So whereas e to the x goes through there, ln x is going to go through there. And whereas this comes from that direction, on ln x, it travels from that direction. So we're going to have that type of relationship, and then it's going to move closer and then travel away again, getting progressively larger. So y equals ln x is going to look something like that. So if you can't remember it, so long as you can remember what y equals e to the x looks like, then you should be able to do that. Now, just to show you that on the graphics calculator, if I clear that one away, then ln x, and clear that away, ln x looks like that. Now mine's, the axis there is spaced out differently to that there, but you can see the picture of what's going to happen. Now, as far as the next part, which is on a separate diagram, sketch the graph of the modulus of that. The modulus of that is going to be exactly the same from there up, but where it's negative, it becomes positive. So that particular graph is going to look like, let's go purple, from here, then up like that. Okay, so I should have drawn a different graph, different sketch, but just so that for speed's sake. So it's going to come down like that to 1 and then bounce like that. There. So let's see if it will look like that in the graphics calculator. Hope so, or I'm in trouble. So rather than lnx, I'm going to plot the absolute value of ln x. And there you go. Again, you can't really see it that clearly because of the axes. I could change the axes, but again, for time's sake, I'm not going to fuss. So that's what you're looking for, okay? But I've shown you there how to build it just from your knowledge of y equals e to the x. Okay, so that's for A, 1 and 2. And then for B is another one of these inequalities. So either the positive value of that must be less than 4, which means 3x is less than 6, which means x must be less than 2, or the negative value of 3x take 2 must be less than 4. Multiply out to get rid of the negative, flips the inequality sign. So 3x must be greater than negative 2, which means x must be greater than negative 2/3. So this time they are continuous. This time you can go from negative 2/3 up to 2. So therefore, we'll take a look at the graphics calculator now. X is between those values. Let's just take a look on the graphics calculator. Clear that, and I want the modulus of 3x minus 2, so absolute value 3x take 2 and 4, and you can see there that we're interested in when this line, or that V shape, is below the line y equals 4. So you can see it's that continuous region from that point there across to that point there. So that point there is minus 2/3 and that point there is 2. Okay, one more to have a go at. Number 5. Solve the inequality 3x take 8 is less than or equal to 5. So hopefully you can see now how repetitive these questions are. So either positive value is less than or equal to 5. Take that over, it becomes plus 13. So either x is less than or equal to 13/3, or negative value is less than or equal to 5. Get rid of the negative, flips the sign, take that over, and you're going to have 3. So x must be greater than or equal to 1. So here, x must be bigger than or equal to 1, less than or equal to 13/3, which is 4 1/3. So again, with this one, it's a continuous region. So 1, x must be more than or equal to 1, but less than or equal to 13/3. Let's just check that on the calculator. Clear that, clear that. Absolute 3x, oops, gone bonkers, sorry, y equals absolute 3x take 8, close bracket, 5, graph it. So there's my bounce, there's my line 5. I want it to be less than or equal to, so it's the region that's below the line, which again you can see is a continuous region going from there, which will be 1, to there, which is 4 1/3. So I'm happy with that. And then part B, given that fx equals modulus of x, sketch the graph of y equals fx. Okay, no worries with that. On the same diagram, sketch the graph of fx plus 2 plus 1. Right, so we'll come to that bit in the middle in a minute. Let's first of all sketch the graph y equals x. Okay, so 1, 2, 3, neg 1, neg 2, neg 3, 1, 2, 3, negative 1, negative 2, y, x, and let's see where we are going. So negative 1, negative 2, negative 3, 3, negative 1, negative 2, 1, 2, 3, 4, 5. Okay, so y equals fx, we know by now is going to go through the points 1, 1, 2, 2, and so on. On the other side, because it's the modulus, it isn't going to continue diagonally down, it's going to bounce back. So on this side, it's going to do that. So that's the line y equals modulus of x. Now, where we're going now is that we are going to translate that graph, and we are going to travel fx plus 2 plus 1. So there's 2 transformations that we're going to make. The first one is the one that's happening inside there, and hopefully you can remember that that moves that graph in back and forth in the x direction, and if it's plus in there, it actually moves it that way too. So that point on the graph is going to move 2 units in that direction, and then this one is going to move it 1 unit in that direction. So this is a translation. It's going to move the graph, and when you write a translation, it's a column vector, and it's going to move it minus 2 units in the x direction and plus 1 unit in the y direction, which is going to take it to there. So that point reaches there, and then everything else then is parallel to where it was originally. So that's going to be the positive part of it. And that's going to be the negative part of it. So this will be y equals fx plus 2 plus 1. So there you go. So those are modulus questions with the WJC. Hopefully you found that helpful.